The first piece is agnostic of any product or solution. The first piece is more the economics of the cloud. And this is kind of an overview that I think will help people who are sorting through what is private cloud versus public cloud, what is infrastructure as a service versus platform as a service, and those sort of questions. Some of you in this crowd may already be aware of these, but I figured that I'd walk you through those to get us on the same page, because it will help us understand Windows Azure platform better and how it differentiates from, say, an Amazon Web Services or an Force.com platform. Okay. And given we have only 20 minutes, I'll jump into this right away. This is sort of a high-level overview of what is happening in the IT industry today. Just like how we had the switch from mainframes to the client-server architecture back in the day, that is the sort of switch that we are having from the client-server architecture to the cloud today. Essentially a paradigm shift in the industry. So there have been times in the recent past, especially in the last 2 years, when people had assumed that, hey, cloud is just another fad that will pass, right? And then what happened was it kept growing, it kept getting attention, it started getting mind share. Even big companies started missing the boat on it and they woke up to it, right? So it's essentially a paradigm shift. It's here to stay, and if anything, it's only going to grow in the coming years. And the research from Gartner and IDC suggests as such as well. There'll be a point in time where the cost will become so compelling that it will just make sense to move to the cloud and you won't be thinking about the alternatives. Sorry, I'm going back. Got it. So there are two things to the cloud, right? When I say that there is the costs become compelling, there must be a reason where these cost savings come from. And the cost savings comes from two economies. One is the supply side economics and the other is the demand side economics. Now let me show you an example of supply side economics. Now this is again agnostic of any company or industry. It is generic explanation for the economics. So what you see in there is data centers built by companies in the recent past, in the last 12 months. This is publicly available information in those companies' financials, right? Look at the kind of locations that they have in there. Camp Williams, made in North Carolina, Baltimore, Princeville. What you quickly realize is you don't find a Chicago in there, you don't find a New York City in there. This is because the companies which build data centers at scale, look at the size of those data centers in millions and the power they utilize, and you'll quickly realize that there are efficiencies that come out of this. The efficiencies are primarily in electricity, in land that they can actually negotiate out. Now, if you're building your own private cloud, you're not going to gain these efficiencies. And another big aspect of this efficiency is cost of hardware, right? Microsoft can buy commoditized hardware from HP or EMC better than you buying it for your private cloud or building your own data center. Same is the case with Amazon Web Services. Same is the case with Google, right? The kind of scale and the componentized hardware that they buy is going to be it's going to make it much cheaper. Electricity is so much more cheaper. The data centers consume as much electricity as a small city. So what they are negotiating is rates that will be super cheap, right? Now these are savings that go into the supply side of things. But the supply side of things is only scratching the surface of economics. What really matters is the demand side of things. Now this is a typical server utilization during the time of the day, 24 hours, that is on-premise. Now what this tells you is, at best, that server box is utilized 30% of the time. In other words, 70% of the time it's sitting there sucking up electricity. Now this is what is happening to most on-premise environments today. Now folks have a reason to have things on-premise, maybe because it's IP, maybe because it's legacy applications that they don't want to move to the cloud. So there are reasons why people want to sustain it this way. But the reality is that 70% of the time a hardware box in a typical on-premise environment remains underutilized, right? Now, how do we compensate for this underutilization if we were to go to a public cloud? Now here is an example. This is a box in Microsoft data centers running Bing search queries, right? All these data that I'm providing you is actual scenarios, right? The blue line that you see there is the Bing search query volume in Great Britain. The one you see in yellow is that of Japan. Now what you see in there is when Great Britain goes to sleep, Japan wakes up. and this usage begins. So in the same box, you're actually utilizing the search query and you're keeping your utilization of your box greater than 70% as opposed to the 30% if you were to use it for just one of the geographies. What we call here is geographic variability. Now apply this to all geographies where Bing runs, or apply this to all geographies where the data center caters to, and you will get a geographic variability which will ensure the utilization of the box is greater than 70 to 100%, right? Now, on top of that, there is industry variability. What I mean by industry variability is, we are coming into the holiday season, and these are companies like Target, Toys R Us, Walmart, and Barnes & Noble, which are all in the retail space. So these guys are going to have holiday spikes when the holiday buying period comes in. Now, historically, before the cloud age, the red one is Walmart. Walmart has to maintain a data center for its peak load that happens in the holiday center for the entire year, right? So they're essentially maintaining a data center to accommodate that 1 month spike right there. Now what will happen now is they can accommodate that spike in a public cloud and maintain just the one they use for most of the year, right? That is one aspect of public cloud advantages. But what you also see in there is, in the same box that these guys run, if it all moves to a public cloud, you can apply different industries to it. For example, the tax industry. Now, the holiday season is between the last 4 months of the year. The tax season is active on the first 4 months of the subsequent year. So the same box can actually be utilized for 8 months instead of 4 months if it were in a public cloud versus Walmart having its own data centers, right? So that increases the utilization of the box in a public cloud. Now apply all the industries across the globe to the structure, and you will find out how much cost efficiencies we can get out of utilizing those boxes 100% of the time. Now with that in mind, so the three things that I talked about was, you have supply side economics on building large data centers that will give you efficiencies in electricity, labor, and hardware. And then on the demand side of economics, we talked about geographic variability and industry variability, right? Now apply this to this logic. You have private cloud, you have infrastructure as a service, you have platform as a service, and software as a service. Private cloud is where you manage everything from networking to applications. Now, I don't want to go so far to make this, the private cloud might be a different term with different companies, but essentially it's an on-premise environment that is optimized for internal use. It is still on-premise, it is still managed by the company. So you manage everything from networking to applications. What you have here is absolute control. You control everything in there, you control the resources, you have what you buy, etc. But what is happening there is you don't get the scale that you get out of supply side economics, you don't have geographic variability, and you don't have industry variability. And that is why the costs become so compelling on a public cloud environment. Now let's switch to infrastructure as a service, the kind of service that most vendors today provide, Rackspace and Amazon Web Services. What you're doing essentially is you're going into a portal, you're provisioning VMs, you're choosing the operating system that you want, and you are responsible for managing the VMs, provisioning additional VMs if required, managing and patching the operating system, and everything on top of them, right? And the day and age of platform as a service, which is where all vendors in the industry are moving to, VMware with Cloud Foundry, Amazon Web Services with Elastic Beanstalk, Salesforce.com with Force.com, and Google with Google Apps Engine, is platform as a service, where all a customer needs to worry about is the application and the data architecture as it relates to the application, and everything else is managed by a third-party vendor. Essentially, this comes back to the basic business school studies that we used to have about 20 years back on core competency, right? Managing IT is not the business of people out there. Managing IT was a requirement that they had to do. But now, what you really have to worry about is the applications and the data as it relates to the applications and the benefits that get out of it, and everything else is outsourced to a vendor. And what has also happened is the cost between infrastructure as a service and platform as a service is almost the same. So why would someone go with infrastructure as a service? And it has become a very compelling argument, and that's why you see most of the industry's IT vendors moving in the direction of platform as a service. And finally, you know what software as a service is. It's out of the box. You don't even own the software, but you rather pay a subscription fee for it and use it through a web browser, right? And that you are all aware of. You've had that right from everything we use from a live.com account to a Gmail or a Yahoo is software as a service that we see today. Right? Now with that, this is where platform as a service falls and Windows Azure platform falls. And I want to address this distinction because over the last couple of days I've been sitting in the Microsoft booth, and a lot of folks came to the booth and their first question was, what is this Windows Azure thing? And some questions were like, oh, is it the Amazon Web Services of Microsoft, right? So I wanted to make sure I put this taxonomy in place before I address platform as a service. Now, Microsoft as a company is one of the first providers of platform as a service. We started with this 2 years ago. The research started over 5 years ago. And we are, in a way, ahead of the market in the platform as a service space. Right? And with that, let me give you a quick intro to the value of service management. Service management is the term that differentiates infrastructure as a service and platform as a service, where you don't have your resources managing and patching an operating system, provisioning VMs, even if it is in a public cloud in infrastructure as a service. So what you get out of that is you reduce the IT complexity. You don't need as much IT administrators managing those machines, even if you're provisioning it in a third-party public cloud. You lower the TCO as a result and a function of that. The scaling is automatic. You don't provision additional machines if you need to. It spikes up. It bills you for the spike as it requires as the load comes in. And you're not really, you don't have, a typical example is Outback Steakhouse. Their marketing team put together a marketing application on Windows Azure platform with absolutely no idea of what IT it is. What that tells you is that there really is the IT focus becomes reduced. The cost of having IT resources managed this comes down or literally goes away over time. And that is essentially helping you with your TCO as well. Now, automated service management is the ability of the system to take care of redundancies, make sure you have the right capacity when you need spikes, manage if your VM fails, automatically manage it rather than expect you to manage it. The OS is patched automatically. Windows Azure is the operating system on top of these data centers. It's patched and maintained automatically. So these are things that you don't have to manage. And with that comes a service level agreement. We want to make sure that if you are willing to put your application on a public cloud, we want to make sure it's always on, it's always running, and it doesn't fail. And we have a service level commitment to it. It's 99.59 apparently. That is the way they do it of assurance that there will be no downtime on your applications. And if at all something like that happens, has not happened for Windows Azure platform before, it's likely not to happen again. But then it is an industry that is subject to connectivity. Data centers have their own risks associated with them, like natural disasters. There is redundancy that we all plan for, but there are instances, as we saw with Amazon Web Services in the last couple of months, things happen on those, so there are SLAs to protect you with those as well. Now, this is the value that you get on top of infrastructure as a service when you go to platform as a service, but it doesn't come at an additional cost. It's almost zero, right? Or rather, it is zero. It's almost the same price. You go look at a compute instance for an infrastructure as a service provider, it will be about 12 cents an hour. Windows Azure platform will be about 12 cents an hour, right? So that is, you get this value at no additional cost. These are typical patterns that we see in the cloud, like what are all the activities that need to move to public cloud. On and off scenarios, a typical example is payroll. Your payroll systems spike up on the 15th of every month and the 30th of every month. You don't have to have an infrastructure that's for the whole month, right? You just need to accommodate those spikes. Growing fast is a typical example of startups, especially those that build apps for mobile phones. They don't know how many users are going to download those apps that they build. They don't know how it will spike, and they don't want it to be down. If it goes down, they lose the credibility. Customers are not going to come back again. So things like Angry Birds and Zynga and Farmville should be active almost all the time. And these are companies that are growing fast that don't know what their capacity would be, that go with public cloud and platform as a service. Now, unpredictable bursting is if you have a typical example is Super Bowl. After a Super Bowl ad, if you have a call to action in a particular website, historically we have seen that some of those websites fail because they really can't take the load on that particular day. This happened in India when I was there in